So to understand what vectors are, you have to know the difference between scalar quantities and vector quantities. Vector quantities are things that have magnitude and direction, and scalars are things that have magnitude but no direction. So scalars only have a size. For example, time, 10 seconds, and mass can be like 30 seconds. And most of the time, scalar quantities can never be negative. Like you can't have a negative speed or a negative time. But vectors are quantities that also have direction on top of the magnitude or the size. And for example, two objects with velocities of 7 meters per second and negative 7 meters per second are traveling at the same speed, but in opposite directions, which makes their vectors different, but the scalars the same. And a vector quantity has components in the x direction, the y direction, and the z axes. And they can be positive or negative. Some examples of vector quantities are velocity, which can be like negative 5 meters per second, or displacement, which can be 30 meters. And vectors can be given in either 2 dimensions or 3 dimensions. Now, let's have some practice identifying the difference between scalar and vector quantities. So first, let's look at number 1. A boat travels at 3 meters per second on a bearing of 52 degrees. And this one has magnitude, size, and a direction. So that means it's a vector. And number 2, it has magnitude, 1.7 meters, but it doesn't have direction, which means that it's just a scalar. So in these type of problems, just look for if it has magnitude and direction, or if it doesn't. Number 3, a car accelerates forward at 5.4 meters per second squared. So you have magnitude and direction. Or if you don't have the forward, the direction might be implied by the positive sign. So this will be a vector as well. Vectors are usually represented using an arrow in the direction that it's going, and the length of the arrow represents its magnitude or its size. And they're usually written in letters either bolded, and you'll see bolded ones in like typed documents or answers, or underlined, and you'll see underlined ones more in written ones. For example, a vector going from point O to A, like right here, can be written as this bolded A. It's not a very good bolded one because it's handwritten, or this underlined A, which you should probably use when you're handwriting it. And this is also like what an arrow for the vector might look like. And in this case, we know the start and end points of the vector, so we can write it in this notation, where you have the start letter first, the end letter second, and then you draw like that kind of half arrow shape above it. And two vectors are only equal if their corresponding components are equal, and we can represent them numerically to figure this out. Usually they're represented using column vectors or base vectors. And so column vectors are where one number is written above the other one, enclosed in brackets or parentheses. And the top number represents the horizontal direction. The bottom number represents the vertical direction for 2D vectors. And for 3D vectors, the bottom number represents the depth or the z direction. So for example, this vector 3, -2 means 3 in the positive direction in the x direction, and 2 units in a negative vertical direction, the y direction. And this one, 3, -4, 2, means 3 in the positive x, 4 in the negative y, and 2 in the positive z. And the other way you can represent vectors numerically is using base vectors, where you use the letters I, j, and k. And I, j, and k are unit vectors, meaning that they have a magnitude of 1. So I is the x direction, j is the y direction, and k is the z direction. So similar to just writing vectors, you can either write the I, j, and k as bolded or as underlined. And again, bolded ones you usually see more in typed, the answers or document, and underlines you'll see more in handwriting. So here I have an example, negative 4i plus 3j minus k. This means 4 units in the negative x direction, 3 units in the positive y direction, and 1 unit in the negative z direction. And so when you're trying to find like the numerical values of vectors, or to see if two vectors are the same or compare them, then you use these notations. And now let's get into some practice problems. If you think you can do this one, pause the video and try it. This problem says write the vector negative 405, which is in column notation, in base vector notation. So we're going to have to convert the notation. So first, let's find out what the numbers in the 0, negative 4, and 5 mean. So as I said earlier, the top number represents the x direction, so negative 4 in x. The 0 represents the y direction, so 0 in y. And the bottom number represents the z direction, 5 in z. And now we convert these to base vector notation, which you should remember is the I, j, and k. In the base vector notation, I represents the x, so we can put negative 4 in front of the I, and the j represents the 0, so plus 0j, and then the z represents, or the k represents the z, so 5k, and underline all of those. Or if you're typing it out, you might want to bold it. But we can get rid of the 0j because 0 times anything is 0, so our final vector is negative 4i plus 5k, or 5k minus 4i, and underline all of that. And that is your final answer. And now let's do another practice problem. If you think you can do this one, pause the video and try it. This one says write the vector k minus 2j using column vector notation. And k minus 2j is in base vector notation, so we're going to have to convert it backwards, unlike last problem. So first, let's think about what the k and j represent. So in base vector notation, I is the x, and j is the y, and k is the z. So for this one, we have the 1 in front of the k, which means 1 in the z direction, so 1 in z, and then negative 2 in front of the j, which means negative 2 in y. And now we convert that into column vector notation. Since we don't have anything for x, the top value is going to be 0, negative 2 for y is negative 2, 1 for z is 1. And that is your final answer for this problem. So, everything that I went through and explained in this video, and all the problems that I did, should give you enough information to have a solid foundation for vectors. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.